Cracks in construction are fissure or fracture that occurs in a building and structure when stress exceeds its strength. As we proceed, please don't forget to subscribe to our YouTube channel. Cracks can be classified as either structural or non-structural, and they can vary in size, shape, and severity. Structural cracks. These cracks can affect the stability, the load-bearing capacity of a building, which can be a sign of serious issues. They can be caused by a number of factors, which including ground movement, clay shrinkage, land slip, vibration, subsidence, settlement, heave, and sway can all cause ground movement. Temperature variations, freeze-thaw cycles, frost, and other temperature changes can cause materials to expand and contract. Moisture movement, excess water, water penetration, condensation, and faulty or damaged drains can cause materials to expand and contract. Poor construction practices, inadequate design, use of low-quality materials, incorrect concrete mixes, and poor workmanship can all lead to cracks. Environmental factors, earthquakes, extreme weather conditions, soil erosion, excessive wind, rain, or nearby excavation work can all impact a building's structural stability. Aging and wear and tear, woodworm, rust, wet rot, and dry rot can all decay the building fabric. Reactive soils. Clay is an example of a reactive soil, which expands when moist and contracts when dry. Poor construction practices, faulty design, overloading, foundation settlement, soil movement, seismic activity, inadequate maintenance. Cracks in construction can result to many disadvantages, including structural damage. Cracks can reduce the structural integrity of a building, making it more likely to collapse or be damaged. Water damage. Cracks can allow water to seep in, which can lead to corrosion of the steel reinforcement and reduce the lifespan of the structure. Health and safety. Cracks can create a threat to human life and spread disease. Aesthetics. Cracks can make a building look unsightly and may discomfort people who live there. Maintenance. Cracks can lead to long-term maintenance issues. Service issues. Cracks can affect the service of certain structures, such as roofs and reservoirs. Special structures. Cracks in special structures, such as nuclear power plants and waste disposal structures, can be especially dangerous. Here are some ways to prevent cracks in concrete construction. 1. Add reinforcement. Use steel or fiberglass bars, mesh, or fibers to strengthen and support the concrete. 2. Keep concrete moist. Cover the concrete with a plastic sheet or mist it with water to prevent it from drying out too quickly. 3. Install control joints. These are pre-planned cuts in the concrete that allow for shrinkage and movement, and help control where cracks occur. 4. Cure the concrete properly. This helps retain moisture and slows down the hardening process, allowing the concrete to settle and strengthen. 5. Cover the concrete. Use an insulated blanket or sheet to protect the concrete from temperatures below 50 degrees Fahrenheit. 6. Use quality materials. Mix the materials properly and reduce the water content in the concrete mix. 7. Avoid extreme temperatures. Avoid placing the concrete in areas with extreme temperature differences. 8. Apply a cement sealer. Apply a high-quality cement sealer yearly. 9. Avoid heavy loads. Avoid placing heavy loads on the concrete. Here are some ways to treat cracks in construction. 1. Crack injection. Involves injecting a material like epoxy or polyurethane into the crack to fill and seal it. This method can be used for both structural and non-structural cracks. 2. Grouting. A mixture of cement, sand, water, or chemicals is used to fill gaps in cracks. Stitching. Anchoring stitching dogs with non-shrink grout or an epoxy resin-based bonding system spreads tension away from the crack. 3. Routing and sealing. A saw or grinder is used to widen the crack at the surface, and the resulting groove is filled. 4. Concrete resurfacing. Instead of removing and replacing the concrete, you can repair and resurface the existing concrete. 5. Applying bonding agent. A bonding agent or primer is applied to the surface to ensure proper adhesion between the repair material and the existing wall. 6. Cleaning the crack. A wire brush can be used to remove any loose debris around the crack. Other methods for repairing cracks include flexible sealing, drilling and plugging, pre-stressing steel, dry packing, and overlays. If this video was helpful to you, don't hesitate to click to that subscribe button for more weekly videos.